the universe is not eternal, at least not in the way we once imagined. For most of human history, we thought the heavens were fixed, eternal, unchanging, a silent backdrop to the drama of life on Earth. But modern science has uncovered a darker truth. The cosmos itself is mortal. Its brilliance is already fading, and in ways more dramatic than anyone could have foreseen. So here's the unthinkable question. Is the universe already dying? At first glance, the night sky offers no such clue. Stars sparkle, galaxies glow, supernovae erupt with dazzling power. From our vantage point, it all feels alive, vibrant, even eternal. But when we measure carefully, when we peer deeper with the most powerful telescopes, we see something else. Decline. Star formation is slowing. Galaxies are aging. Black holes are awakening in ways that drain the cosmos of its light. Join me today as we travel through time from the fiery birth of the cosmos to its inevitable demise. Along the way, we'll witness the rise and fall of galaxies, the treachery of black holes, and the slow suffocation of all that was ever bright. Our story begins in a paradox. The very forces that once gave life to the universe are now conspiring to extinguish it. The same gravity that gathered gas into galaxies now drags them into collisions that can strip away their future. The same black holes that regulate star formation can, if they feed too greedily, destroy entire galaxies from within. But here's the twist. The death of the universe is not a far-off event. It has already begun. Scientists now believe we live not in cosmic morning but in cosmic twilight, a time when the golden age of starbirth is already long gone, and what remains is only the long slow decline. How did the universe go from overflowing with new stars to slowly choking on its own silence? To answer that, we must travel back to its most glorious chapter, the peak of creation when the cosmos blazed with light as never before and never again. Cosmic noon. When the lights peaked, there was a time when the universe blazed. Astronomers call it cosmic noon, a turbulent era roughly 3 to 4 billion years after the Big Bang, when galaxies were ravenous and the sky was busy with birth. Gas streamed along invisible filaments of the cosmic web like rivers feeding a growing delta. Where those rivers met at the nodes, galaxies ignited. Back then, star formation was over 10 times the pace we see today. Entire neighborhoods lit up at once. Clouds collapsed by the thousands, turning cold hydrogen into furnaces of fusion. If you stood on an ancient world during that epoch and looked up, there would be more naked-eye stars than you could count. It was not a quiet universe. It was a construction site. But even at its height, the seeds of decline were being sown. The same inflows that fed young galaxies also triggered pressure waves, shocks, and winds. Starbursts bred supernovae, and supernovae bred feedback great outflows that heated gas and tossed it into the galactic halo where it could no longer cool and settle. Creation had a cost and the bill would come due. Meanwhile, collisions reshaped the landscape. Galaxies merged often, sometimes gently, sometimes catastrophically. In the most violent unions, gas clouds were compressed into a frenzy of starbirth, then blown apart by the very stars they created. Imagine a forest so fertile it grows itself into a wildfire. That was cosmic noon, and yet something even more decisive stirred at galactic centres. Supermassive black holes, quiet regulators, and calmer times woke to feed on streams of gas. Their accretion disks blazed across the spectrum, their jets drilled through entire galaxies. In moderation, they pruned growth. In excess, they sterilized it. Cosmic noon was glorious, but it was also self-poisoning. So why didn't this engine run forever? Because the universe doesn't just evolve in place, it expands. With every passing eon, the web-stretched densities fell and the fuel lines thinned. The banquet could not be sustained. How the cosmos learned to say no. To make a star, you need 3 things: gas, gravity, and time. To stop a star, you only need heat. Heat puffs gas up, keeps it buoyant, and denies gravity its grip. The universe discovered this trick early and used it everywhere. Start small. A newborn cluster breathes fire. Massive stars blast ultraviolet radiation and launch winds that sweep a nebula clean. Then they die, some within a few million years, with supernova shockwaves that punch cavities in the interstellar medium. Those holes connect, forming porous chimneys for hot gas to vent. The neighborhood cools more slowly. Fewer clouds collapse. Starbirth slows. Scale up. Entire galaxies surf on feedback. Starbursts launch galactic winds, vast outflows carrying metals and dust into the halo where they linger like heat haze. Cooling times lengthened. Gas that once fell readily to the disk now stalls in a warm suspension unable to condense. If the inflow weakens at the same time, say, because cosmic expansion starves the filaments, the galaxy's fuel tank drops below ignition. Then there's the black hole veto. Accretion flares heat gas not just locally but galactically. Radiation pressure shock cones and especially relativistic jets can inflate lobes of hot plasma tens of thousands of light years wide. That energy doesn't create stars, it prevents them, and the paradox deepens. The more massive the galaxy, the more massive the central black hole and the more decisive the shutdown. Dust, the quiet accomplice of star formation, plays both sides. It cools gas efficiently, enabling collapse. But when outflows drag dust into the halo, it becomes part of the insulation layer that keeps gas hot. The same grains that midwifed stars become the veil that delays their successors. Feedback isn't a switch, it's a thermostat with hysteresis. Once a galaxy gets too warm, it doesn't cool back quickly. The engine sputters, coughs, then idles. In extreme cases, it stalls altogether. Astronomers call it quenching a cold word for a hot process. So the great paradox arrives. The universe's most productive era built the very tools that ended it. Creation made its own breaks. Walk the morgues of the cosmos, the giant ellipticals, the massive spheroids, the silent graveyards of stars, and you see a pattern. Their colour has shifted from blue-white to red, a sign that short-lived high-mass stars vanished long ago. What remains are long-lived dwarfs flickering dimly along with the ashes of stellar evolution. White dwarfs, neutron stars, and the dark gravities of black holes. How did these cities of starlight die? Not by a single cause, but by a conspiracy. Repeated mergers choked their centres with gas, until the central black hole lit up, sterilized the core, and drove the remaining fuel outward. Cluster environments stripped their reservoirs with ram pressure, a wind made of hot intracluster plasma that peels gas from a rushing galaxy. Others simply exhausted their supply and never got it back. Cosmic logistics failed. The strangest murders leave signatures. Jellyfish galaxies trail tendrils of star-forming knots, proof of stripping in action. Stellar streams arc across halos, fossils of swallowed companions. Radiolobes balloon from the core scars of ancient jets. In some, the disk remains, but it's empty of cold clouds. In others, even the disk is gone, replaced by a near-featureless ellipsoid. Not every galaxy dies young. Some, like our Milky Way, idle at a modest pace, turning a handful of suns per year. But patience is not a cure. The supply lines are thinning and our calendar is long. The cosmic actuarial tables do not lie. All galaxies will age into redness. Some will go quietly. Some will go with a last burst of fireworks. None will shine forever. And yet the autopsy offers more than grief. It offers a diagnosis. The universe is past its prime. That's not a metaphor, it's a measurement. The cosmic star formation rate peaked billions of years ago and has fallen ever since. We are witnesses not to the dawn of light, but to its long evening. If that's true, what comes after evening? Does the universe simply dim into sleep, or is there a deeper betrayal ahead? Dark energy. The expanding silence. Expansion was already the universe's plot twist. Accelerated expansion is its final act. In a cosmos driven by dark energy, space doesn't merely grow, it grows faster with time. Structures that are not gravitationally bound drift apart, redshifting each other into invisibility. The more the universe expands, the more capacity it has to expand. It's a feedback loop with no off switch. What does that mean for galaxies? It means supply chain failure at scale. The filaments that once funneled fresh gas into halos stretch thin. Inflows weaken. Star-forming disks sputter. Even without violent quenching, a galaxy starves. Think of civilization with empty roads. The cities still stand, but the caravans never arrive. On larger scales, dark energy redraws the map. Distant galaxies recede until their light is stretched beyond detectability. The cosmic microwave background continues to cool and fade. The ultimate baby picture becomes a ghost. In the far future, observers in our island group will see only their local-bound collection and nothing beyond. The universe will look small again, not because it is, but because the rest has slipped over a horizon of speed and time. Dark energy doesn't rip stars from galaxies. Gravity defends what is bound. but it does ensure that what's lost stays lost. No fresh gas from outside, no new mergers from afar, only the long accounting of internal reserves. And once those are spent, there is no bailout, so the decline is double. Physics inside Galaxies says heat the gas. Cosmology outside says thin the pipes. The combination is devastating, slow, inevitable, and almost polite. The universe dies not with a bang, but with a subsiding breath. But a whisper can carry. In the depths of time, do new wonders arise, rare sparks in the dark? The answer is stranger than it sounds. Long twilight, embers that refuse to go out. Fast-living giants vanish first. It's the humble stars that inherit the future. Red dwarfs miserly with fuel can burn for trillions of years, far longer than the universe has currently existed. In the long twilight, they dominate the sky, faint but stubborn like coals that refuse to die. As metals accumulate, star formation itself changes character. Cooling becomes easier, the minimum viable star mass drops. Exotic outcomes appear at the margins. Barely their stars, glowing just above the threshold of fusion, their surfaces cold enough to host frost, their cores warm enough to sip hydrogen for ages. Where binaries of brown dwarfs collide, a true star can flicker on a match struck in an abandoned city. But every ledger balances. White dwarfs bleed their heat into space, sliding toward invisibility. Neutron stars spin down. Black holes feed rarely and quietly unless a stray passerby wanders too close. Entire planetary systems drift apart in slow gravitational pinball ejected into the deep. The fireworks stop. The choreography continues. Against this hush, galaxies still act. The Milky Way and Andromeda merge, then merge again with their companions, forging a single island of stars. The local group becomes a local one, an oval of light floating in an expanding dark. Inside, the last cold clouds form the last modest generations of suns. Outside, silence accelerates. Is this the end? Not yet. Even after star formation ceases, physics remains inventive. Frozen iron hearts, possible exotic fusions, black hole whispers, each a new dialect of light. The universe does not give up easily. It changes the rules of its radiance. But change can be another word for diminishment. Every era illuminates less volume, fewer actors, narrower bands. The grand play becomes a monologue, then a murmur, then a breath. Black holes have always been the accountants of the cosmos, tallying mass and momentum with ruthless efficiency. In youth they regulated galaxies. In middle age they rationed fuel. In senescence they become the final collectors, sweeping up strays, swallowing the unbound, cashing out the last kinetic chips on the table. A quiet black hole is not asleep. It is patient. It waits for gravitational chaos to deliver it crumbs. A wandering dwarf star, a loose gas streamer, an unlucky planet. Each meal flashes a brief flare, then fades to infrared embers. Over absurd spans, central black holes grow even as their cities empty. But even the bookkeepers have a deadline. Quantum fields hum at horizons. Hawking radiation lets black holes leak. The bigger they are, the colder and slower the leak, but time is plentiful in a dying universe. Given enough zeros on the clock, every event horizon unravels. The ledger burns itself. After the last black hole evaporates, the universe enters a weirder quiet. No macroscopic engines, only particle whispers. Whatever complexity persists is held together by feeble forces over ridiculous distances. If there is meaning left, it sits in the statistics of noise. And yet if we've learned anything from cosmic history, it's that the universe surprises us. It found ways to ignite when it was thin. It found ways to regulate when it was crowded. Might it find ways to shimmer when it is almost empty? Physics hints at possibilities. Rare tunneling events, exotic condensates, improbable fusions in frozen matter. None make a new dawn. Some sketch a longer dusk. A future astronomer will see less not because there is less to see, but because horizons move inward. The wider cosmos recedes beyond detectability. The fossil light of the Big Bang fades beyond inference. Without a cosmic backdrop, even the past becomes hard to prove. The universe will look provincial again, an island without charts. Does that mean truth disappears? Not quite. Physics leaves invariance relationships between things that do not rely on distant evidence. Gravity still curves space. Quantum fields still fluctuate. Thermodynamics still tallies loss. But the story grows incomplete. The archive goes dark. That is the final cruelty of a dying universe. It doesn't just dim the lights, it erases the records. Meaning survives where it can be remembered in structures that endure long enough to carry it. Stars once played that role, then planets, then minds. In the very long run, none are safe. So why tell this story now? Because we live in the brief luminous window when the cosmos is both bright and knowable. We can see our origins, model our future, and understand the mechanisms that brought us here. Against a timeline of trillions, our moment is a spark. But it is also a summit, and there is a deeper consolation. Endings give shape to middles. The fact that the universe will die does not make it less magnificent. It makes it precious. The physics that writes the last chapter also wrote the first and everything we love in between. Echoes of the first light. Every ending hides its reflection in the beginning. To grasp how the universe fades, we must return to when it first ignited. For nearly 400,000 years after the Big Bang, there were no stars, no galaxies, only a seething plasma so hot that atoms could not exist. Photons ricocheted endlessly, trapped in an opaque fog. Darkness wasn't the absence of light. It was the imprisonment of it. Then came recombination. Electrons bound to nuclei, atoms formed, and photons were set free. That release still glows around us as the cosmic microwave background, a faint whisper stretched thin by billions of years of expansion. It was the first message, the first signal, the first memory the cosmos left us. But like everything else, it will fade. In 100 billion years, it will be too redshifted to detect. The first light will go dark. What followed was stranger still. The cosmic dark ages. Hydrogen and helium drifted in expanding space, cold and featureless. No stars lit the void. No galaxies stitched filaments together. If you could have stood in that abyss, you would have heard silence so profound it defies description. And then ignition. The first stars' titans of fusion erupted like beacons. They were nothing like the sun. They were hundreds of times its mass, blazing with ferocity, living fast and dying young. Their supernovae forged the first heavy elements, carbon, oxygen, iron, the raw ingredients for everything to come. But their brilliance was brief. Within a few million years, they were gone, leaving only black holes and enriched clouds behind. This was the universe's first betrayal. Creation inseparable from destruction. To make light, it had to ensure death. To seed planets, it had to burn through giants. Every gain was purchased in loss. If the universe began its story this way, sudden ignition, rapid death recycling into the next act, then perhaps its twilight is not a collapse but an echo. Not one death, but a rhythm of diminishing cycles. The question is, how many cycles remain? The rhythm of creation and decline. The universe breathes in waves. It does not simply expand, it pulses with eras. The age of first light gave way to the age of galaxies. The age of galaxies gave way to the age of clusters. Each epoch more complex, more structured, and paradoxically more fragile. At cosmic noon, the rhythm reached its crescendo. Galaxies collided, merged, and lit up. For a time, everything seemed to accelerate. More stars, more dust, more black holes feeding. But crescendos do not sustain. Energy disperses, heat accumulates, and order succumbs to entropy. In physics, it's not poetry, it's inevitability. Today we sit in a quieter measure. Star formation in the Milky Way produces only a handful of suns per year. Clusters that once blazed now drift into sedate equilibrium. The rhythm is slowing. Astronomers can graph it. A bell curve of starbirth peaking billions of years ago and declining ever since. We are living on the downward slope, and yet the cosmos resists silence. Even as the pace falls, creativity persists. Stars still form, galaxies still merge, black holes still flare. The universe is not dead, it is dying slowly. And that distinction matters because slow deaths leave room for strange surprises. But this rhythm has a grim conductor, entropy. Each transformation spreads energy. Thinner reduces its usefulness, makes the next act less likely. Entropy does not forbid complexity, it taxes it. Every star pays that tax. Every galaxy pays it, and eventually the whole universe will default. So the rhythm is more than history, it's prophecy. The arc from simplicity to brilliance to silence is not unique to life or planets or stars. It is cosmic law, which leaves us with a sobering thought. If the universe itself is subject to this rhythm, then perhaps everything we know is just one brief phrase in a song that is destined to fade. Entropy, the silent dictator. If there is a single law that writes the fate of the universe, it is entropy. Unlike the flamboyant forces of gravity or electromagnetism, Entropy is quiet, patient, and absolute. It is the tendency of energy to spread, to equalize, to dilute its own usefulness. When a star shines, it is paying entropy's tax, turning ordered nuclear fuel into a haze of photons. When galaxies collide, they trade their neat orbits for chaotic ones. When black holes feed, they swallow information into horizons that may never return it. Each act of creation is also an act of surrender. On human scales, entropy looks like coffee cooling in a mug. On cosmic scales, it looks like the fading of starlight, the thinning of gas, the darkening of skies. Over trillions of years, entropy doesn't just win, it erases the scoreboard. The universe approaches thermal equilibrium where everything is the same lukewarm nothingness. No gradients, no flows, no engines, no life. This fate has a name, the heat death of the universe. It is not fire but frost, not explosion but stillness. Imagine a cosmos where every black hole is evaporated, every star has cooled, every particle drifts alone in expanding space. Motion continues but meaning disappears. Some physicists protest. Isn't this too simple, too final? Perhaps. Entropy is not destruction, it is redistribution. And sometimes redistribution allows new exotic orders to appear briefly. But entropy never forgets. It is the one account that never forgives debt. The cruelest part, heat death doesn't arrive in a sudden catastrophe. It creeps in increments, stars dying, galaxies, reddening horizons, slipping away until the silence is complete. By the time the end is obvious, it will already have been unfolding for eons. Alternate fates. Crunch, rip and bounce. The universe may be dying, but the manner of its death is still contested. Heat death is the front runner, but other candidates lurk at the edges of theory, dramatic, violent and strange. The Big Crunch imagines the universe reversing course. Expansion slows, halts and turns into collapse. Galaxies that drifted apart are dragged back together. Temperatures rise, densities soar. And in the final instant, the cosmos implodes into a singularity not unlike the one from which it was born. If true, then perhaps the Big Bang was not a beginning, but a heartbeat in a cycle of births and deaths. But so far, dark energy's acceleration makes this unlikely. The Big Rip is even more terrifying. If dark energy is not constant but grows stronger with time, it could eventually overpower even gravity itself. First galaxies dissolve, then stars are torn from planets, then planets are shredded into dust. Finally, even atoms are ripped apart as space-time itself fractures. The end arrives not in silence but in violence, a universe shredded down to its quantum threads. Then there is the Big Bounce, a phoenix scenario where contraction leads not to finality but to rebirth. Some models of quantum gravity suggest that the singularity of a crunch would rebound into a new expansion. If so, then our universe may be only one cycle in an endless chain. Every death would be a womb, every silence a pause before another crescendo. Each of these scenarios is speculative, but each carries a lesson. We do not know as much as we think. The cosmos hides its cards well. Our measurements today favour eternal expansion and heat death, but a subtle shift in dark energy's nature could flip the script entirely. So the universe confronts us with another paradox. The farther we look, the less certain the ending seems. Twilight has already begun. Look around our night sky. It feels vibrant, endless, eternal. But astronomers measuring the cosmic star formation rate know the truth. The universe's golden age ended billions of years ago. We are not in cosmic noon. We are not even in cosmic afternoon. We are in the evening. Our own Milky Way creates just a few stars each year. That may sound abundant, but compared to its past, it is meagre. 10 billion years ago, galaxies produced stars at a rate 10 times higher. Today, most galaxies are quiet suburbs rather than bustling cities. The light we see above us is largely the light of stars already burning, not the glow of new ones igniting. This is twilight, not metaphorical but measurable. The decline is in progress. Cosmic surveys confirm that the universe is dimming. The proportion of blue star-forming galaxies shrinks. The red quiescent ones multiply. It is as if the universe itself has entered middle age, its vitality ebbing, its energy dispersing. And yet twilight has its beauty. The skies remain full, the constellations familiar. We exist in a rare window where the universe is both old enough to be understood and young enough to remain luminous. That balance will not last. Consciousness at twilight. Why do we exist now and not in some other era? Cosmologists call this the coincidence problem. Out of trillions of years the universe may endure. Why are we alive during the brief sliver, when stars are still plentiful, galaxies still visible, and dark energy only just accelerating expansion? The answer may be selection. Life as we know it depends on the heavy elements forged in stars, but not too many generations in, or they would be locked in dead remnants. Civilizations require stable planetary systems, neither too chaotic nor too sterile. Consciousness blooms best in moderation between the violent dawn and the silent dusk. If that is true, then our existence is a mirror of the universe's own trajectory. We are children of twilight. We arose in the narrow band when the cosmos still burned brightly, but had cooled enough to craft planets, oceans, and DNA. In a very real sense, the universe had to age before it could know itself. But that awareness comes with weight. To know that the universe is dying is to feel a double mortality, our own and the cosmos's. And yet there is wonder too. For the first time in 13.8 billion years, the universe can look back at itself, measure its own decay, and write its own elegy. Reading the universe's medical charts. Astronomers are physicians of the cosmos taking its vital signs. They measure redshifts to check expansion counts, starbirths to track metabolism, observe black holes to gauge stress. The charts are clear. The patient is stable but in irreversible decline. Deep field surveys with the Hubble Space Telescope and now the James Webb Space Telescope reveal the cosmic history of light. They show galaxies small and chaotic in youth, luminous in maturity, and tired in age. Simulations like Illustrious TNG and Eagle recreate this arc with millions of virtual galaxies confirming the pattern. A steep rise in star formation, a peak, then a long tail of fading productivity. We can even quantify twilight. At cosmic noon, the universe formed stars at a rate over 10 solar masses per year per galaxy. Today the Milky Way manages just 1 or 2. In a trillion years that number will be 0. The cosmos is not a patient that might recover. It is one moving predictably toward hospice care. But the charts reveal more than decline. They show causes, feedback loops, dark energy, environmental stripping, quasar activity, all written in the data. The universe is not dying of one disease. It is succumbing to a web of interconnected failures. In a way, it is not dying at all. It is simply completing its growth cycle. The black hole paradox. At the heart of nearly every galaxy lies a monster, a supermassive black hole. For years, they were thought to be passive, irrelevant specks compared to the galaxy around them. Now we know the opposite. They are the regulators of growth, the engines of decline, the paradox at the center of it all. When a black hole feeds it, unleashes more energy than billions of stars combined. This energy can sculpt galaxies heating and expelling gas-halting star formation for millions of years. And yet without them, galaxies might have burned their fuel too quickly, exhausting themselves even sooner. Black holes both prolong the cosmic dance and now terminate it. Observations of galaxies like M87 show the aftermath. Jets of radiation stretching thousands of light-years, lobes of plasma marking the crime scene of galactic death. The Event Horizon Telescope captured its silhouette a black scar against infinity. It looked like the culprit caught in the act of the murder weapon still hot. So we face another irony. The very centers that gave galaxies their order are also the agents of their demise. Creation and destruction are not separate, they are entwined in the same engine. What does it mean for everything to end? It is one thing to chart decline, another to confront its meaning. If all galaxies fade, if all stars cool, if even black holes evaporate, then what remains? Does the universe end in silence, or does it transform into something beyond our comprehension? Entropy suggests finality, equilibrium, nothingness, no gradients left. But physics often surprises us. Out of plasma came atoms, out of atoms came stars, out of stars came life. At each stage, new forms emerge from apparent exhaustion. Could even the death of the universe hide seeds of novelty? Some theorists speculate about quantum tunneling events, vacuum decay, or exotic matter states that could give rise to new structures. Others dream of multiverse cycles, each death feeding the birth of another cosmos. But certainty eludes us. The best we can say is that the universe as we know it will end. Its familiar lights, its galaxies, its stars, its planets all will vanish. What remains afterward may not be the universe at all, but something unrecognizable. And yet perhaps that is enough. Knowing that even the cosmos is mortal reminds us of our own fragility, but also of our moment's magnificence. To exist in the brief era when the universe still shines is a gift no future epoch will hold. Earth under a fading sky. From our small blue planet, the decline of the universe is invisible. The sun still blazes, the Milky Way still arcs overhead. Telescopes still collect light from galaxies billions of years away, but every photon we catch is a message from the past, not the present. The farther we look, the younger the universe appears. The present-day cosmos is dimmer than any telescope can directly reveal. Earth itself is caught in a shorter countdown. In 5 billion years, the sun will swell into a red giant, scorching the planet and stripping away its oceans. Long before the heat death of the cosmos, our world will be uninhabitable. And yet Earth is part of the larger story. The fading of fuel, the aging of stars, the relentless arithmetic of entropy. Our night sky is a privilege of timing. Future civilizations, if any survive, will not see what we see. Galaxies beyond the local group will vanish into the accelerated expansion invisible forever. To them, the universe will look empty as if their island were the only one. They may never discover cosmology at all, so we live at a rare intersection. A habitable planet orbiting a stable star in a galaxy still active enough to study the cosmos while it is young. We are cosmic witnesses standing at the window of twilight. And the view is extraordinary. The longest goodbye. The future of the cosmos is not measured in centuries, millennia, or even millions of years. It is measured in trillions. In that vast calendar, entire civilizations rise and fall in the blink of an eye. Trillions of years from now, red dwarfs will still burn faint but steady. When they finally exhaust their hydrogen, they will fade into black dwarfs, cold embers in the dark. Occasionally, two brown dwarfs may collide, striking a brief new spark. But each flare is rarer than the last. After 10 to the power of 20 years, most stars are gone. Galaxies dissolve as gravitational encounters fling their stars into intergalactic exile. Black holes dominate the night-silent collectors of the last matter. Over still greater spans, even they evaporate via Hawking radiation, releasing faint whispers of heat until they too disappear. Beyond one Google years, the universe enters a new age. The dark era. No stars, no galaxies, no black holes, only particles drifting endlessly through a space that continues to expand. It is not violent. It is not sudden. It is the slowest, longest goodbye in history. Exotic endings. Physicists are not content with silence. They ask, could the end be stranger than we imagine? Some speculate about iron stars, hypothetical remnants formed when quantum tunneling allows protons in black dwarfs to fuse into iron. These stars would be dark, cold, and nearly eternal, glowing only faintly as they shed their last scraps of heat. Others point to vacuum decay, a catastrophic possibility rooted in quantum field theory. If our universe exists in a false vacuum, it could one day tunnel into a lower energy state. The transition would expand at nearly the speed of light, rewriting physics itself, obliterating all structure. No warning, no survivors, just a sudden change of rules. Then there are ideas even wilder. Boltzmann brains, self-aware fluctuations of matter arising from random quantum noise. If entropy rules forever, then given infinite time, consciousness might appear again by chance. But would that be life, or just the cruelest parody of it? Each scenario is speculative, but each shows the same truth. The cosmos is not guaranteed to die quietly. Its decline may hold surprises stranger than any beginning. Why knowing the end matters? If the universe is doomed, why should we care? Because endings give context to beginnings. Knowing the fate of the cosmos sharpens the meaning of our present. We are temporary, yes, but so is everything else. Galaxies, stars, and even space-time itself share in impermanence. To realize this is not despair, it is perspective. Our lives matter not because they last forever, but because they happen now in the thin, luminous band between chaos and silence. For scientists, studying cosmic death is not morbid curiosity. It is the continuation of a journey begun when humans first looked at the stars. For philosophers, it is a reminder that permanence is an illusion. For all of us, it is a call to wonder. In a universe destined for silence, we are the brief symphony of awareness. Full circle, the story of the universe begins and ends in darkness. At the dawn, there was a hot, dense fog, a silence waiting for stars. At the dusk, there will be a cold, thin emptiness, a silence after stars. Between those silences lies everything, galaxies, worlds, life and thought. In that span, light fought darkness. Hydrogen fused to helium, gravity, sculpted suns. Chemistry gave birth to biology. Awareness arose, and for a fleeting moment the universe looked back at itself. That moment is ours. So is the universe already dying? Yes, the decline is measurable, inevitable, unstoppable. But death is not the opposite of life, it is its frame. Without it, nothing would matter. With it, everything becomes precious. When the final star cools and the last black hole evaporates, the universe will fall silent once more. But silence is not nothing. Silence is a canvas. Perhaps on it new symphonies may one day be painted. Or perhaps not. Either way, we were here in the brightness in the knowing. This is the story of the dying universe. A story still being written in starlight, and one we were fortunate enough to read before the ink fades forever. Dark matter, the invisible architect of decline. We speak often of stars, galaxies, and black holes, but the largest actor in this story is invisible. Dark matter. It outweighs visible matter by a factor of 5 binding galaxies in its silent grip. Without it, the Milky Way would have unravelled long ago. Yet in the long run, even dark matter cannot save the cosmos. Dark matter shaped the web of galaxies, sculpting the scaffolding on which everything luminous hangs. It guided the first clouds into collapse, seeded the first galaxies, and maintained their coherence. In that sense, it was the midwife of creation. But gravity is impartial. The same dark matter halos that once sheltered galaxies are now stretched thin by dark energy's expansion. Their role is less guardian, more undertaker. And there is a deeper mystery. We do not know what dark matter is. It may be a particle beyond the standard model or a shadow of something more profound. If it decays even slowly, then the universe's decline is not only inevitable but accelerated. In that scenario, the very skeleton of the cosmos crumbles. Imagine the irony. The invisible force that gave galaxies their strength might also dictate the terms of their extinction. If so, then cosmic death is not just written in starlight, but in the silence between stars. For billions of years, planets have been the quiet witnesses of cosmic drama. They orbit stars, cradle oceans, nurture atmospheres, and occasionally give rise to life. But what happens to planets in a universe that is running out of fuel? First they lose their suns. Stars like ours will swell, scorch, and shed their outer layers. Some planets will be engulfed, others will be cast into freezing exile. Around red dwarfs, worlds may endure for trillions of years, but their skies will dim as the stars themselves flicker out. Planets without stars wander the void, rogue worlds drifting in darkness. Some may carry subsurface oceans heated by radioactive decay, or tidal forces tiny pockets of warmth in an endless night. Could life persist there? Perhaps, but it would be a lonely persistence. Even the planets that remain bound to long-lived stars face slow decay. Tidal forces will drag moons into their hosts or fling them away. Atmospheres will leak into space. Over unimaginable spans, collisions will grind rocky worlds into rubble. Civilizations, if they endure long enough, will face stark choices. Abandon their planets for engineered habitats or find ways to harness dwindling starlight with impossible efficiency. And when the last star fades, even ingenuity may not be enough. Human beings once imagined the universe as eternal. To discover its mortality is both terrifying and liberating. If the cosmos itself will one day perish, then permanence is an illusion, and impermanence is the only constant. This realization has ancient echoes. Philosophers spoke of cycles of fire and rebirth, of worlds rising and falling. Modern cosmology confirms their intuition. Nothing lasts, not even galaxies, not even time itself. The scale is larger, the physics sharper, but the theme is the same. So what do we do with this knowledge? Some feel despair that all efforts are futile if the universe ends. But there is another view, that transience is what gives beauty its sharpness. A flower that never withers is scenery, not miracle. A star that never dies would never seed the chemistry of life. A universe that lived forever might never have birthed us at all. Seen this way, the death of the cosmos is not a tragedy. It is the frame that makes existence meaningful. Our moment matters not despite the end, but because of it. Humanity's cosmic diary. If the universe is destined to erase its own records, then memory becomes resistance. Every observation we make, every image from Hubble or James Webb, every equation written on a page is a diary entry against oblivion. We are the first beings, as far as we know, to measure the cosmos with such clarity. We have traced its birth in background radiation, mapped its growth in galaxies, and projected its death into trillions of years. In doing so, we have given the universe something it never had before. self-awareness. But how long will that awareness last? Our digital archives may not endure geological time, let alone cosmic time. Paper burns servers, corrode even spacecraft decay. Perhaps our best hope is to scatter records across the stars, messages etched into durable media launched beyond the Milky Way, in the faint chance they survive longer than their makers. Even if no one ever reads them, these records matter. They are proof that for a brief era the universe knew itself. That knowledge is fragile, yes, but it is also luminous. Rebirth in the silence. Is death the end or a transformation? Cosmology does not answer, but it whispers possibilities. Some theories suggest that our universe is one bubble among many, and that when ours fades, another may ignite. Others propose cycles, expansion followed by contraction, collapse followed by rebound, a heartbeat across eternity. Still others hint at quantum fluctuations, where even in the emptiest dark, new sparks may appear. We cannot prove these ideas. We may never prove them, but they remind us that the universe has always been stranger than expected. Who foresaw atoms in plasma, or galaxies in chaos, or life on a rocky world orbiting an average star? Perhaps the end is not final but fertile. Perhaps silence is not nothing but a canvas for another story. And even if that story never comes our own, was still written in stars, in minds, in memory. The universe is dying, but in its dying it has birthed the most improbable thing of all. Awareness that it is dying, and that awareness is ours. Life in the long night. When the stars fade, what becomes of life? For now we know it as fragile, bound to light and warmth. But in a darkening universe, the definition of survival must expand. Some speculate about civilizations around red dwarfs, tiny suns that can live for trillions of years. These stars burn so slowly that their planets may enjoy stability far longer than Earth ever will. If intelligence arises there, it may witness epochs beyond our comprehension. But even red dwarfs have an end. Other scenarios are stranger. Rogue planets with subsurface oceans could shelter microbial life warmed not by sunlight, but by internal heat. Could such life persist for billions, even trillions of years hidden in icy shells, while the galaxy outside grows silent? If so, life might never completely vanish, it would only retreat waiting in shadows. But intelligence demands energy. Civilizations need more than scraps of heat. They need power to think, to build, to dream. In the long night, energy becomes the rarest currency of all. The cosmos itself conspires against endurance, leaving the question open. Can life outlast its stars, or must it surrender to the islands? Dreaming beyond limits. Humanity has always resisted boundaries. Oceans, mountains, and skies were once barriers. Now they are pathways. But the limits written into the universe are different. They are not logistical, they are fundamental. The speed of light, the scarcity of fuel, the inevitability of entropy. These are not walls to climb, but laws to obey. Yet dreamers persist. Some imagine building Dyson spheres around stars, harvesting nearly all of their energy. Others imagine moving stars themselves, dragging suns into safe harbours to extend their lifetimes. In the far future, advanced civilizations might learn to tap exotic sources. Black holes, spin quantum fluctuations, or even the decay of dark matter. But here is the paradox. Every strategy still bows to entropy. Energy cannot be created without cost. At best, we can delay the inevitable. We cannot erase it. The universe is not a puzzle we can solve, but a stage we can perform upon until the lights dim. Still, perhaps that is enough. To live longer, to know more, to carry awareness farther into the abyss, this is not immortality, but it is defiance. And defiance too is meaning, the horizon of knowledge. Knowledge is light. It pushes back, darkness reveals patterns and tells us where we are. But knowledge, like light, has a horizon. In a universe that expands forever, that horizon creeps inward until much of reality slips beyond reach. Future astronomers will see fewer galaxies not because they vanish, but because their light will never arrive. The cosmic microwave background, our oldest record, will fade into nothingness. Even the fingerprints of expansion may grow too faint to measure. At some point, observers may conclude they live in a small, static cosmos. The truth will be gone not because it changed, but because it escaped observation. So there is a cruel irony. We alive today may be among the very few generations in all of cosmic history capable of knowing the universe's true story. We arrived at twilight, yes, but twilight is the moment when the horizon is widest, when the view is richest. We live in the golden hour of knowledge. But even now mysteries persist. Dark matter, dark energy, quantum gravity, our picture is incomplete. If knowledge has a horizon, perhaps we will never see the full portrait. And yet maybe that incompleteness is the point. Curiosity is not diminished by limits. It is defined by them, our place in a mortal cosmos. For thousands of years, humans wondered about the heavens. Now we know the heavens are mortal too. That knowledge is humbling, but it is also empowering, because it means the universe is not a cold, eternal backdrop. It is a partner in our story. We are stardust, yes, but we are also starlight, brief and brilliant. Our thoughts, our art, our questions, all are temporary flashes in a temporary cosmos. And that makes them more valuable, not less. What we do in our finite moment becomes our answer to the infinite. Civilizations may fall, worlds may perish, galaxies may fade. But the fact that awareness ever arose at all is a triumph against odds so immense they almost defy language. Even if the cosmos ends in silence, the song has already been sung. Perhaps our purpose is not to escape mortality, but to embrace it fully, to marvel, to understand, to record and to love, knowing all the while that it will not last. That fragility is the source of beauty, the miracle of now. The universe is dying, the evidence is clear, the timeline inevitable. And yet look around. The stars still shine, the galaxies still wheel overhead, the Earth still hums with life. The miracle is not in what will happen trillions of years from now. The miracle is that we are here now, able to see it, to know it, to wonder at it. Mortality gives meaning to every sunrise, every discovery, every fleeting joy. A cosmos without death would also be a cosmos without urgency, without story, without us. The fact that it ends is the reason it matters. So let us not mourn the universe's fate. Let us marvel that in its vast unfolding there came a time when hydrogen burned into stars, stars forged heavier elements, planets formed, and one of those planets asked, what will become of it all? This is our moment. This is our window, and though the lights will one day go out, the wonder they inspired will remain for as long as we carry it, and perhaps beyond. The universe may end in silence, but in us for now it speaks. Epilogue, the elegy of a mortal cosmos. The universe is vast beyond comprehension, yet fragile in its fate. For centuries humanity gazed at the stars, believing them eternal, believing the heavens to be the stage of gods or the machinery of forever. Today we know better. We know the cosmos is not timeless marble, but living fire, and like all fires it will burn down to embers. This knowledge is both humbling and electrifying. On one hand it strips away illusions. There will be no infinite sky, no everlasting galaxy, no immortal suns. Every star will cool, every planet will freeze, every atom will drift apart. The great structures of the cosmos, spiral arms, clusters, filaments will collapse into silence. In time, even the black holes, those final sentinels of gravity, will evaporate into whispers of heat. On a long enough timeline, the universe becomes indistinguishable from nothing. On the other hand, this truth amplifies the significance of now. Consider the odds. 13.8 billion years of cosmic evolution, countless accidents and collisions, an immeasurable ballet of atoms, and in this fleeting moment, we are here. We can see galaxies at the edge of visibility. We can hear the echo of the Big Bang and microwave radiation. We can chart the future until the last light fades. We can know. That knowledge itself is a miracle. Think of what that means. Stars do not wonder if they will die. Black holes do not contemplate their own evaporation. But we do. In us, the cosmos has developed the rarest of faculties. The ability to reflect, to ask questions, to wrestle with inevitability. Awareness is not an escape from mortality. It is the flowering of it. Without death, awareness may never have existed. So perhaps the universe's ending is not tragedy, but culmination. It is the final chapter of a story that was always finite, always precious, always improbable. When the last star cools, the last photon fades, and the last black hole evaporates, there will remain only one undeniable fact. That once against all odds, the universe knew itself through us. And maybe that is enough. Maybe the meaning of a mortal cosmos is not to last forever, but to be noticed, to be understood, to be cherished while it burns. When future civilizations, if any endure, look back at this brief era of brightness, they may marvel that the universe ever achieved such clarity of self-reflection. For us, the lesson is simpler. Live as though every moment is as rare as a star, because it is. Every sunrise, every discovery, every act of wonder is a defiance of silence. We are the universe's way of celebrating its own fragile light. So when we ask, is the universe already dying? The answer is yes. But it is also still alive, still radiant, still telling its story in the language of starlight. We are part of that story. We are the witnesses, the recorders, the brief symphony before the long silence. One day silence will come, but today the stars still shine. And while they do so, do we